Today we are going to look at the history of databases. And we will ask a very controversial question: are modern document databases simply repeating the mistakes of the past? When NoSQL and document databases became popular recently, a huge debate started. Engineers began arguing fiercely about how we should connect data together, especially for complex, tangled, many-to-many relationships. But this debate is not new. In fact, if we look back to the 1970s, during the very first days of business computers, programmers were having the exact same argument. To understand how to build systems today, we must understand the three major models of the past. Let us start with the very first one, the hierarchical model. In 1968, IBM released a famous database called IMS. This database was incredibly important because it was originally built to manage inventory for the Apollo space program, helping to send humans to the moon. IMS used a very simple design called a tree structure. It nested records inside of other records, like branches on a tree. Does that sound familiar? It should. The data model that sent humans to the moon looks almost exactly like the modern JSON files we use today. But it had a fatal flaw. Just like JSON, the tree structure was perfect for simple one-to-many data. But if you had a complex many-to-many relationship, the tree broke down. It did not support joining data together. Developers were forced to either manually copy data over and over, or write messy code to link things. It was extremely painful. To fix the problems with the tree, engineers invented something new, the network model. The network model, also known as CODASYL, tried to fix the tree by allowing a record to have multiple parents. To do this, they used something called pointers. A pointer is like a physical map that tells the computer exactly where the next piece of data lives on the hard drive. Look at the diagram on the screen. Because everything was connected by pointers, reading data was a nightmare. It was like being trapped in a giant, invisible maze. To find the data you wanted, you had to write computer code that manually walked through the maze, following pointer after pointer. We called this the access path. If you made a mistake in your code, or if the maze changed, your entire application broke. It was terribly inflexible. Then, Edgar Codd proposed the relational model, which became SQL. It changed everything. SQL looked at the horrible, confusing maze of pointers and threw it in the garbage. Instead, it simply laid all the data out in the open. Everything was put into flat, clean tables, made of simple rows and columns. There were no confusing pointers or hidden paths. But the true genius of SQL was a piece of software called the Query Optimizer. Think of the optimizer like a modern GPS navigation system in your car. With the old network model, you had to manually drive the car, turning left and right through the maze. With SQL, you just type in the address of the data you want. the query optimizer automatically calculates the absolute fastest route and gets the data for you. You never have to think about the maze again. So, let us answer our original question. Are modern document databases like MongoDB just repeating the mistakes of the 1970s? The answer is a mix of yes and no. Yes. They have returned to the exact same nested tree structure that IBM used for the Apollo space program. But they learned from history. When dealing with complex many-to-many relationships, modern document databases do not use the confusing, fragile pointers of the old network model. Instead, they use simple ID numbers, exactly like SQL foreign keys. By understanding the failures of the past, we can build much better systems for the future.